This particular video, we are going to look at how we're going to compare that of decision tree regressor and that of the linear regression, which actually perform very well. We're going to make use of a data I have here, which is our house price data set here. So first of all, we're going to actually load it on our environment. Then we're going to actually to visualize, and then I'm going to explain some stuff from there. So let me just, this in our previous video, this is what we were able to cover on how to save and load your model and use that your model to actually make decisions. So I'm going to create a variable called df as usual. So it's going to be pandas. That, remember that we imported pandas as that of the word pd. So we're going to say our csv. We're going to read a CSV file because this is actually a CSV file. So I'm just going to copy the. Remember that this data, this house price data set is on my GitHub, and link to this data set or to my GitHub is to be in description down below. So I want to read this house price data set here. So I just basically copy this. So I want to print this of our data frame here. So let's actually print it. What it's basically going to do, if I run it, it's going to print the first 5 and then the last 5, and then it's going to put dot dot. So that's not actually hard to actually explain. So after that, I'm going to explain the data that we're actually working with. The reason I want us to make is decision tree regressor and that of the linear regression. I just want us to solve a little bit problem on that of the regression side, because most of the time we have actually been solving on that of the classification side. So let's actually look at this. This is the data we're actually going to predict on. Our target is the price, to know price. When I mean price, I mean the price of stuff that maybe the price of a particular house, because when we look at this is actually the name house price data set. So the first for this we have how many input feature. We have 1, 2, 3, 4, 5, and then 6, and the target, which is going to be our price. When we look at this data we have here, this is actually a regression data. I can say a regressor type of can say data, because this is actually continuous. This is not a discrete data that we see on that of the classification based model, classification based data. So on this of our row 0 that we have here, the first we have here is bedroom. The bedroom column, the first is that of the 4, and the second one, the room has that of the bathroom. When we have a room that have 4 bedroom, 2 bathroom, and the area, the square root feet of the area, this actual square feet area, like the more like the land mass is more than 655, and the location rating, location rating, how well do people actually rate the location. That actually makes sense, because that actually makes sense, because people have to rate the location, because houses if you come to Nigeria, houses in maybe somewhere around maybe some non-popularly known state compared to that of Lagos or Abuja, you can see that the rating is going to be far different. So we have this of the age of the house. You can say the house is just 6 years, it's actually fresh, and it has a garage. So when we look at this house definitely going to be expensive, but comparing it to this house that have 5 bedroom, 3 bathroom, square feet area is quite huge, and the location rating is 9. Age of the house 45,000. Age of the house can also affect, because house that is 45,000 years, Jesus Christ, who want to live there? But the price is still definitely going to be huge, because the bedroom is high, the bathroom is high, the size of the house is high, the location rating is actually that high, and the age of the house was actually a little bit low. So we can see that this is actually 688,000. So this is actually 423,000. This actually makes sense, because the more the smaller the size, the more the price. That actually makes sense. So we're going to make use of our that should be our decision tree regressor. Decision tree regressor we have actually imported is part of that of the sklearn.tree decision tree. This is actually decision tree regressor. I actually imported this. So I remember I'm going to try my best to keep this at the simplest possible, so I don't need this again. So I'm just going to print out. I'm going to set my S. This guy should shift a little bit so I can see where. So our S is going to be our df, our data frame dot what iLog. I want to make use of the iLog, so it's going to be, I want the all rows because it make use of the formula of that of the RC, rows come first and then colon, and I want the colon, but I don't want the one of the last index, so it actually makes sense. And for our y, let me just come down here for our y I want all rows, the colon I want to use the last index of the colon, so this is going to be for our y. Everything looks good for our training. So for what this x means is going to start from 0 to this of the garage. The last one is going to be neglected, and for the member is going to take all rows. This signifies all rows, and for the y is going to take all rows, and then it's only going to take the last element, which is this price. So this actually settles this. So the next we want to actually declare our model. So this is going to be model. So our model is going to be our decision tree. This is actually the decision tree regressor. I'm not going to set any parameter. This is why I'm not setting any parameters right now. Is want to actually do is to fit our model. As you can say, model dot what fit, want to actually fit it on that of the s and the y, but instead of fitting our model directly to this s and the y, so we want to actually reserve a data that we want to actually use for testing purpose. So we can actually make use of that of train test split. I have a script that actually covers that, so I don't need to actually type it again. This is it. Let me just actually copy this. Actually train test split. So we are going to reserve 20% of our data for testing. So what we actually did here, just when we do this train test split, they were splitting our s and y. So for it's as if it's going to cut it into two, but it's not going to cut it. It's going to cut it in the ratio of the test size we actually set it. So the test size, this is 0.2 signifies 20% for the testing. That is what. So for anything S test and for our Y test is the data that the machine learning model have never seen before. So what we are going to do next, and for the training, since 20% is being reserved for testing, and for the training is now going to be reserved of 80%. So we are going to use the remaining 80% for the training of the model. Hope this is not actually confusing. So if it's confusing you, if you have been following my video, this tutorial, there's no way, it's never going to confuse you. But if it's confusing you, this is actually what we did. We splitted the s and the y. With what we mean by s and y, this data frame, remember, I was signifying as if this entire guy will have down here. We splitted it into two. Maybe let's assume that's from here up, because it's bigger than from to down. So we have that of the from up here, from here to up is 80%, and from here to down is 20%. So let's assume that these two rows is going to be for the testing that the model have never seen before. Just you're going to pick it randomly, and for the for the training, it's going to pick it also. So at this, hope that actually solve the problem. So the next we are going to do, we can actually use it to make prediction, and then we are going to evaluate this of our model. There are many ways to evaluate it, but we are going to make use of the three ways we have actually been using to evaluate our linear model. Remember that this evaluation matrix is actually based for that of the linear model. So which are the matrix? I think that it should be means here, that should be mean squared error, and that of the mean average error, and that of the R2 score. So I think I will do similar things. So I'm just going to get the script, then I'm going to explain that in really well. So we want to also draw the graph. So let's just copy this. Let's just paste it down, so make things easier. So what do we want to actually, here we are going to use the model to predict. They were going to check how well it performed on our what S test. Because remember that the S test is the data that the model was reserved for testing. Hope that is not hard to understand. So then we are going to check this of the mean squared error, mean average error, R2 score. Remember that the lower the mean squared error and the mean average error, the better our model is. So, and then we are going to plot a graph of these two guys, which is going to be now what we are going. This is the original data that we are going to actually plot. In our case, that is the original data is actually that of the original data that we are going to plot. The original data is going to be the data that the model have not seen, which is going to be our our S test and there is going to be our what? Y test. Remember that the model have never seen it before. So now we're going to plot our S test against what the model predicted. So it's going to be S test. Hope this is not actually hard to. So we'll give the label. This is the actual. So remember that what I actually did here is that X test is what the model have never seen before. Remember, and this of the Y test. So it's just like the X and Y. The S and Y has been splitted into two. Some parts have been seen by the model, which is the model used for the training, which is that of the S train and Y train. So the other S and Y that model have not seen are that of the S and the S. So that's what we set. We give it a scatter plot, so it's going to be like a dot dot. Remember that I explained this scatter plot in my previous video on that of the matplotlib. How to make use of matplotlib to actually draw graphs. So in case if you're interested, the link is also down in the description down below, so you can actually check it out. So in this of the plot, we are going to plot out of the arrow, I can say the lines, to try to fit that of the what is it called, the actually, whether the actually was actually giving us, whether what we predicted was how well was able to go for that of the actual. So we hope this is not hard to actually understand. Let's actually go back again to explain what we actually did here. So we gave it out. This is actually where we read this data this CSV file, this house price here, and then we printed it here to actually explain how it actually works and how this actually being structured. Then the next we actually give our S and Y. X is for the future, Y is for the target. So hope that now the target is going to be that of the price. So find input value with consistent sample 500, 1000. Why do I have this? What is this? So we're getting some kind of gibberish. Why do I have this? And then this is our Y predict. So the Y predict, this is actually our Y predict because we don't have any other outputs here. And then we have the MS. The MS, this is where the problem came up. So there we have the mean system number of sample 5,000 to 1,000. But we got our Y predict to actually happen. Okay, when we look at this, I found out there's a little bit of 5,000. So the first problem that we're facing here is that we actually set off our Y instead of our that of our actually the true Y, which means the true Y is that is supposed to be that of the Y test. So that's actually not just Y. Y test. Remember that I copied this earlier, so I forgot to do some stuff actually. Sorry about that. So this actually fixes it. And also when I look at this of our, when we're trying to plot our graph here, we're going to have a little bit of problem because when we look at this, our S test is actually two-dimensional, if I'm not mistaken. So this actually, let's go up. This is actually supposed to be, they are like, it contain multiple columns, if I might say. So that is not like when we actually try to print it here, so it can contain multiple features. So what we can basically do is just actually to make use of one particular column to plot against, because our target is that of the Y. This is actually plotting, I can say, giving us plotting the real, can say the real data, and this is actually the predicted data against the real data. So what we can basically do is to, on this of our S test, we are going to pick one particular feature. So we can say and make use of our iLog. We want all the rows, and which column do we want to actually. So let's say, let me just make use of column 0. I know that from our data, we know that column 0 should be, I think that should be bedroom or bathroom. Yeah, I can't show him. What have I done? I'm only interested in this dot iLog. So paste it here. So it's going to make use of, I think that should be bedroom. This is going to be the bedroom column, and then this bedroom column against the actual and the predicted. Let's actually see that on our screen. So from the look of it, why do we have this? For the look of it, this is all actually, but let's look at our, what is more important here to me is more of our MSE and our MAE, and this of our R2 score. So remember that R2 score just tend to tell us how well the model was able to explain that of the variation within our data, and this of the MSE, the lower the value, the better our model. You can see this is actually 21,000, even on how small our data and how the input does not even relate to that of the output, or sorry, the feature does not even have anything to do with the input. Models didn't actually perform really well. This is actually 716 million. This is actually a high number. So when we look at the graph, the line is actually bashed up. So instead of all make use of line, we can actually make use of this of the scatter also. So the scatter is now going to be also going to be that of the is now the blue color. So we're going to look at ones that actually mapped on maybe on each other. So the ones that actually mapped on each other are those ones that the model was actually able to predict correctly. Remember that this model, you can actually save it in case if you want to actually use it for a later purpose. You can actually save the model. You can see the model was able to actually perform a little bit well. Guys, it was able to classify a whole lot of them really well. You can see the blue was actually what the model predicted, because that is actually we set it. Blue predicted, red actual. That's actually what we set here. The label will give it. I'll make use of legend. So I explained this on my and the matplotlib tutorial in case if you're actually interested in it. So have this of the white text, the color red, and for the predicted blue. So this actually explains this. So it wasn't able to predict this particular one wasn't able to predict one, but was able to predict some of other ones. So our model was actually pretty good. Well, not actually pretty good, but actually did its best. So let's actually make use of that of the regression. Sorry, not regression. Linear regression that we have here. They are both so that of the linear model. So let's see how where our regression is going to perform. So I don't want to get this y predict again. So I'm going to go for that of that's linear regression. I think let's actually run this. So when we look at this, the value of our MSC, this is 135, 135, and for this gave us 703. However, our MAE to be 10,000, and this was 21,000. From the look of it, this is actually 99. It seems as if our linear regression performed better than that of the his other competitor, which was actually that of the decision tree regressor. There's actually many ways to actually check how true this is, and when we look at the graph, they are basically almost the same thing, just that this guy, the linear regression performed better than I actually anticipated. So both of them, they did their best, even though some of them are almost predicting rubbish. Even though the data is actually small, so they actually did their better than I expected. But linear regression was outperformed that of the decision tree regressor from the look of it. So, but I'm just surprised. There's no way linear regression will beat decision tree regressor. But as you can see on this of our data that we have here, I think that is basically the case on this of our house price data set that we have here. This was actually what was actually being predicted. So I think this actually we're able to understand how we can actually predict data, make use of that of the linear regression and that of decision tree regressor. Remember that this problem was actually a regressor problem. You can actually make use of that of the classification to actually solve this, but this is not a classification based problem, but doesn't actually really account much. But regression problems should be made use of regression model. Classification model should make use of that of the classifier or the classification model. So I think this concludes it for this video. In the next video, we're going to look at some of the problem beginners actually faces when just getting into that of the machine learning field. So that was basically what we are going to look at in the next video. So if you are actually interested, or if you're a beginner, you want to actually know some of the problems that some of us might have actually faced, or some of the problems that I faced myself. So when I was still in getting to that of the machine learning field. So that's basically some of the things we'll be looking at in the next video. So I'll be happy to see you in that next video. Thank you for watching.